Good morning. Welcome to TRITEC's webinar with today's topic, eDesigner and Electric. My name is Stefan Wagner and I'm very pleased to show you in this session the two sections, eDesigner and Electric. The webinar will be done in form of, let's say, a presentation. So again, if you have joined last week's sessions, you already know that questions can be posed as email. Best is you answer the invitational email, so it's going to be pointed to the right person. So if you have questions, please send them by mail. Also, if you want to during the meeting. The webinar is recorded, so there will be also a link after the session that will be provided to your to your mail address by mail in order you can have another look and maybe during your next use of the tool and eDesigner you may have two browser windows open, one with a webinar that's then running, and you hit pause at any time, and then you do the corresponding steps into your inside your project, and so step by step you could proceed in finishing your design. Okay. First things first. You as you see, there's the eDesigner tab is now present, and if I go back to the position tab, you remember this is the project from last week. So I'm just rendering that into a 3D total view scene, and you see the building and the surrounding landscape. So that's the project for today. And if I go back, and also as a matter of fact, it absolutely makes sense that eDesigner is not in front here somewhere between, let's say, PV modules and design. It's behind statics by a reason, because we think that, once you said, well, where's my project? How does the building and the roof or the roofs look like? What kind of module do I like to use? How is the fixation? How do I like to pin the modules to the roof? How do I like to work with the layout, the potential layout? Am I satisfied with the statics and also with the mounting of the module? Well, because mounting speed is also critical in our opinion. And then once you're satisfied with all these things here, then in our opinion it actually makes sense to enter eDesigner. And once you enter eDesigner for your first time, same as in MapDraw, for example, you will be prompted with a dialog or a message which helps you, gives you some hints of how the tools can be used. If you don't want to see that again, just click this checkbox and hit close, so you're not bothered any further with this splash screen. You could invoke that by clicking this question mark here, and also this question mark is a bit more context related. You see that's inside this area, so it's a bit more context related and gives you some more hints and details about the PV planning itself. Before we start the planning and the design itself, let me take the opportunity to give you some details about this left-hand pane and how let's say the usage of the eDesigner itself in terms of software. On the left-hand side, as you see, there's a pane with several sections and several functions inside these sections, and you can see, well, there's this section overview, there's this section display, graphs, and edit. In the overview section, you have the planning overview, and you could have one or more layouts. And these layouts will have some indicators of their nature. So that means there's an inverter selected, there's a consumer selected, there's also a battery selected, and at least one of the dimensioning layouts was calculated or simulated. The next is the display. So here with the display, you have the dimensioning layouts with actually now two different layouts. You could see, you can display the yield values and the energy balance per years. The next section is the graphs, where you see the output and the yield losses of a specific planning and a specific dimensioning layout. So there's a kind of hierarchy here inside these three tabs and or three sections, and the lowest section here added is, let's say, a global section where you can edit the project horizon and some graphs that are about to be displayed here. So, and everything that's active is bold, and everything that's not active, or let's say it's not in terms of regarded as present now in the visualization, is not bold. So, just as an example, if I go to the output section here in the graph section, and I would like to get some outputs, you see I'm still the auto layout planning is active, and now from the dimensioning layouts from the inverters. This one is active. I could now change to that. If I click here to the tree core layout, I will remain here in the output section. That's where I am physically, if you want to. But I just want to see now how the results of the output will now be displayed if I switch the dimensioning layouts. And same goes for the yield losses. So I could switch that back and forth. And you see all the time, this will be automatically updated and all values will be recalculated. So now what stands behind the dimensioning layouts? Well, actually, in the auto layout, I said, well, I would like to use SMA as a provider of inverters, and I would like the software to provide me some automatic layouts. So layout means, combination of one or multiple inverters to meet the demands in terms of modules and size of the modules, so size in terms of electrical size of the module, what would suit best for the roof. And now, you see, this is one layout where you have on the west side of the roof, you have one tree power core 1 with multiple inputs. Per input, one or multiple strings, and per strings, a defined number of modules to receive, the amount of modules that needs to be met in terms of the inverters, because you don't want to leftover modules on the roof, which will be not corrected. And same goes for the east side here. Let me just go back to the planning section, and let's say we would like to start with a new layout. So or start with a new planning, and let's say we keep that layout here and the planning completely as it is. We set it as inactive, so that's actually possible. And just from here, you see, we have several roofs, we have the manufacturer, we have a selected variation, that's the tree core, which equals 2 sunny power core 1s, as you've seen here in the display section of the dimensioning layouts. We have selected some consumers, some batteries. So we have taken multiple things in regards to do the simulation. And as you've seen earlier, that's the result of the simulation and the specific dimensioning layout, which takes everything, the simulation which takes everything in regard that we set in the planning section. We said, we take a load profile that's trade and commerce, and we said, with this load profile, this general load profile, had a consumption that was the customer provided by the customer with 150,000 kilowatt hours annual consumption. So we said that's inactive because we want to use, we would like to create a new planning. And that's a very, very good benefit of eDesigner, that you're not pinned. Let's say there's no metric that you need to say, there's one PV planning here inside the tool, tree design, which is pinned to one eDesigner planning, you could create several plannings to one project, with the sense of maybe you have multiple roofs, multiple buildings, and you say, well, one planning is taking everything in regard, and another planning would be just one or two roofs, maybe different consumption profiles, or, and that's also interesting, different layouts or different manufacturers, because not every manufacturer is really pinning their inverters to a specific to all specific layouts or number of modules. So it sometimes really makes sense to compare the manufacturers themselves. So I'm keeping that just for, storage if you want to, just for backup if you will. I could collapse everything here, so it's no longer present in my visibility, and I could say, well, add planning. And it's actually the same as you would do it with a new project, with the difference that the add planning button will be present here, but if you enter a eDesigner with a project where there's no planning existent, here in the middle section a huge plus sign will be present, and you could just click that. So you really will be facing what to do. It's really bold there. So once you start your planning, a blank planning will appear. And maybe we start here with the settings tab. Do some explanation, not all actually, but some basic explanations to the settings. First two tabs here, or two values here, is the minimum power ratio and the maximum power ratio. So the inverse calculation, so module power, DC over AC, so that's the inverter power. And you could say, well, I would like to have a 80% on that as a minimum value, and a maximum value of 120%. So that's typical figures here. Maybe you have a northly oriented roof, and then 80 is certainly too high. Maybe you would like to change the boundaries then to whatever, 50 to 60. Or 50 to 70 or to 80 or something like that. So you get better results, which are really better suit the demands of a northerly oriented roof. If you just as an example, minimum and maximum module temperature. These are basic values, and they certainly will be overwritten by climate data that will be taken in regard by the simulation itself. So once you're designing a roof, which is whatever, let's say somewhere in the northern hemisphere, not to mention a specific country where the winters are very cold, where you certainly have lower values than minus 11 or minus 12 degrees. Or you're in the southern part, let's say Spain. Now I'm just mentioning southern part of Europe. Maybe we say Spain. And maybe you would like to be more precise and say, well, yeah, I would like, I'm sure, pretty sure the maximum temperature will be higher. And as you know, yeah, the higher the temperature, the less is the output of the module. Good. Number of results. Yeah, if you let the software find the best variations of the of inverters, this is the maximum amount of results, and I will have a deeper explanation once we do the automatic layout. Number of 5, that's sufficient enough. You could change that to 20 if you want to. And maybe we just do that for or let's say 10. It doesn't alter the time for finding the right variations. It's not doubling the time here, but actually we try to do the sorting as good as possible. Well, maybe I do the explanation right now. We try to do the sorting in the variations that we use as less as possible inverters, a number of inverters, because you don't want to end up in having 10 inverters if you could do the same with, let's say, 1 or 2. Because it's probably more expensive to have more inverters, even if they are smaller from their dimension. And maybe it's more failure on systems. Maybe it's, and certainly it's more amount of time that's needed to mount these and connect the modules to these, and etc. So you certainly want to have the results on top where you use less as possible inverters, plus the combination of the most efficient ones. So yeah, maybe if you're really pinning, you're trying to find the maximum efficiency, you end up in probably having more inverters than less. But as I said, yeah, on the commercial side, it's not really desirable, probably. So, but at least we try to find the combination of most efficient, highest efficiency of inverters and less inverters. So yeah, 5 is good. 10 could be done. You enter a value of whatever you want. These values, interesting, yeah. Pollution, degradation, wind power penetration, ventilation. Let's say these 3 first. Just leave them as they are. Yeah, pollution. You could add them. You could say, well, snow dust here. Maybe yeah, you're somewhere. I don't know, somewhere in Norway, for example. Maybe the dust is really less, or just a few dust particles flying through the air. Maybe if you're in Europe, let's say, yeah, we take Sierra Nevada, very beautiful site there. But yeah, definitely more dusty level, more pollution on the modules themselves. Yeah, degradation. Yeah, you could add here some value. Most of the time, yeah, you will actually take 0 as a value here. Cable losses, you could also say, well, I want to limit that. Actually, I don't have any idea currently how much cable I do want to use, and you could limit that to whatever, 0 or whatever. 2 is very conservative, 2%. It's really high value, but yeah, we like to be more conservative. And you could change that to any value. These values, once you change them, will not be stored in your default settings. So make sure every time you do a new planning or a new project to check the values in the settings if they have changed, and reset them to your personal desire. And so the rest is more or less self-explaining. Yes, one hint what people, most of the planning are lacking and people are missing is the ventilations of the module, which is very critical. So in our example here, we have a pitched roof. We could unventilated would not be suitable. This would be for in-roof systems. Moderately, yeah, that's what we would choose here. And heavy ventilated, yeah, that's actually if you have a flat roof and an elevated system, please make sure to go into the settings because you have a drastic heat, especially in the southern parts of Europe. It's a drastic change of the annual yield if you make choices here. So just as a hint, be aware of that. I cancel that. I do not any changes here. So first things first. I could provide a different name here. So just clicking on that, and let's say I'm naming that auto layout. Very, very, very creative here. Auto layout 2. This is not mandatory. It's you could do that if you want to. It's easier to separate these because then it could, even if it would be here in the output section, and if I switch here, I would remain in the output section, but I could change the plannings to get a better impression here. Maybe I would like to compare these 2 plannings. So it's a good idea to change the name, even if you have a smaller screen. Then maybe parts of this name will be hidden. So it's a good idea to have speaking names here, just as a hint. Next step is to add the roofs. And you could say, well, I would like to just add one roof to the planning if you want to. If you hover with your mouse over the name of the roof, you see there's a small icon that gives you an idea as an indicator which roof area it actually is. I mean, the naming also tells it west and east, but maybe it, in your project it doesn't, and that's a good hint. So you could add these one by one, if you want. I'm just deleting them, or could delete them and say, well, I just want to use the east side, or delete both of them. Could also say, well, I would like to add all roofs. Yeah, pretty much self-explaining. The eye icons, if you click on them, there's a small dialog opening. So that's the roof name. Yeah, very exciting. The alignment. Yeah, that's interesting. That's something you would also see in the roof section here. And the inclination of the roof itself. That was what we defined in the roof section. And the PV modules, and that's interesting, that's the alignment of the modules to the roof. Yeah, that's not really interesting here, because it will be, most of the time, it will be 180 degrees and 0 degrees, because it's roof parallel, so it's not elevated on the roof. So that's also an indicator that you could see, well, these modules are not elevated on the roofs, they're following the exact roof pitch. So 6 degrees is that what's really taken in regard. Here with the modules, you part of the data sheet of the module will be displayed here again. The output of the module itself, the number of the module, and the total output in watt for this roof area and for this roof area. There's no summary here, but you could do the math. I mean, it's most of the time, yeah, it's easy to do. So next step is that you would like to select the inverter if you want to do a automatic finding of the best variation of inverters. If you would like to say, well, and that's what we're going to do later, you would like to do, you actually have in mind what kind of specific inverter you would like to use. Then you don't start here. You say, well, you really dive directly into it in adding dimensional layouts manually. We will do that later. We would like to say, well, the software should show its benefit. So we click here on the pen, and you see this lower pane opens up, and you choose from the manufacturers that here in TRIDESIGN are available. And in our case, we would like to use SMA. And here you see now the inverters that are provided by TRITEC-Energy here and are available inside the TRIDESIGN tool for finding for the findings or the calculations. So now these are all the inverters. You could say, well, in my special particular case here, I don't want to let the software use the FLX Pros and the Sunny Boys. It just should use the TRI-Power and the TRI-Power Core ones. And you could also limit that, and you could say, well, these should not be used whatsoever. Or reselecting them, or you could say, well, deselect every and just find whatever, use these, maybe. Or you could say, well, I would like to restrict all these, not on a specific module or series level, but on their capabilities. Let's say just those with one input. Or with two inputs. Combination will here on the input side, one or two, and two. This is and 1, 2, and 3. Logically, this doesn't bring a result here. In my opinion, actually, most of the users actually know what they're doing. So restriction here on this area is not actually really needed here. My advice would be, well, just let the software do its work. So I'm not limiting anything here. I click on calculate variations, and you see how fast that goes. So you have the 5 results, and I could say, well, have a look at these results. So every result is highlighted here with this border, and you see. So let us read this here. So we have one time the Sunny TRI-Power Core 1 with a nominal capacity of 50,000 watts with a maximum power D on the DC side. So what the modules are producing of 51,000 watts, and a nominal power ratio in this specific project and the specific use, DC over AC, of 117%. So more DC over than AC. You know so that means it's a little under sized, if you will, which will probably lead to stop a function in for a couple of minutes or in the summertime, but probably a better performance in wintertime and early spring or late fall, for example. And if we expand that, so you see this little arrow, so you want to click on that, the arrow turns, and you see, well, this inverter has 1, 2, 3, 4, 5, 6 inputs. And these inputs have, for A, 1 string with 19 modules, B, 1 with 20, 2 with 70, etc., etc., and the roof area, so east, 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 east. It actually makes sense. And this is west, 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 west. And it's probably the same. So we have here 19, 20, 17, 22, 21, and 18. So this is somehow looks the same, but it seems to be a different variation. And yeah, you see the numbers here are different. So actually, yeah, you need to decide which one of these in terms of stringing makes sense. So in our example, I'd say, well, I would like to keep that. And just as a practical hint, I tend to unselect everything and then to just select the variations, the ones that I really want to use. So this is something I would like to use. And I would like to, well, actually, this doesn't make sense in my opinion. Lots of, but maybe be more efficient, maybe just a bit more annual yield that will be provided, but this combination could be possible. I'm not going to use this, but I would like to compare it to this variation. So 3 times sunny tree power, 20,000 minus 30. And you see, well, actually 2 inputs, 1 input with 2 modules, 2 strings, 22 modules per string, and on B it's 1 by 21, and this pattern 3 times each side. Remember, we have the same amount of modules on each roof, which does not be necessarily the case in your projects, and it's also supported that you have different types of modules on different roof areas that will be taken in regard here. That's actually no stopping point. So. Let's say we are satisfied with these 2 variations, and we say, well, use these variations. And now maybe that's the point where we would like to switch from planning to display, and we see these 2 variations here again. And actually, we get a bit more detail. And yeah, I'm collapsing this here again because I'm assuming that we have the very same variation and combination of strings and modules on the west side and as on the east side. I'm just assuming we could have a look later. What do I see here? So I do see a bit more. I see again, yeah, the input A has 1 string, 19 modules. You see the current here. So this graph is current and force. Just need to always translate that and get in mind in English about these 2 values here. So that's current and that's force, and that's the nominal power ratio for this input, and the same goes for the next inputs here, and also here you see. And you see, it seems to be that I'm in the boundaries of the specification here of the inverter itself. And yeah, somehow here I'm in the lower section of the nominal power ratio. Here I'm, maybe too high whatsoever. And same goes here for the automatic layout too. Maybe here it's a bit more appealing because we don't have so many inputs, so you see that all on one page. I could do, let's say, to get a better impression here, I could say, well, let's do an inverter check. And actually, that's something that's already done in the background. Once you say, well, I would like to use a variation in the background. This check will be performed automatically, but you could do it at any time after that. And I just do that to give you an explanation on that. So inverter check does nothing more or less than, limit value is that what's written in the data sheet. And the value here is the calculated value according to the project. So we say, let's say the check is done here on minimum AC voltage. Minimum is what we have on this project is 400 volts. And the minimum value that is accepted is 277. Maximum 400. Maximum accepted by the inverter is 485. So all these values are green. So the overall check is green, and same is here on that side. Maybe you say, well, for whatever reason, and I'm sure it will not work out here. So that's a bad example, but that's the one we're going to use here. Is maybe say, well, this is interesting. I would like to use this inverter, but I would like to change the assignment of modules to strings here. And, which you can actually do. Just click on that button and you see, well, this becomes editable. So I could say, well, this should be on west side of the roof or back to the east side, both for both inverters. And you see, well, that this is very important. Let's say the global check. The needed modules and the current modules, and it should be, or it must be the same, unless it's not the same, you're not able to save it here. So once I do a change here, let's say only 20 modules, you see, well, this is red. So, and also you see the volt, so the force is changing. It's getting lower, yeah, by nature. If I change the amount of strings, the force remains the same, but the current is raising, which is also pretty much self-explaining. So a number of 195 need to be connected. 65 are connected, so 30 modules are missing. Well, actually, yeah, you see, you get the idea. It's not possible to do that here. Maybe yeah. Just for demo purposes, 189, 95. So this might work. Let's save that. It's really weird, but let's save that. And you see, that's something that I really wanted to see. And you see, well, here it looks like that we're out of the boundaries of the limitations of the inverter itself. And you see, well, that's the proof here. So we have a voltage, a maximum MPP voltage at minus 12 degrees centigrade of 1,115 volts, and the maximum that's accepted is 800. And the input here, it's even more, or somehow on the same level drastic. So it's not possible. We're way outside the limitations and the boundaries. So we need to change the strings, and let's do it like it was before, 22. And you could also, well, edit it here by just clicking into it and give the precise value here, and we save that. And so we're totally fine. That's the result we had before, and let's say for demo purposes, we're gonna leave it like that. So let's say I would be satisfied with these two combinations. They're not simulated. You see, well, it's they're waiting for that, but before we want to simulate that, we have some additional task. In my opinion, yeah, the naming here, automatic inverter, and you see ... And if you hover, yeah, you see layout 2, but that's somehow lame. Yeah, I would like to give it a speaking name, because automatic inverter layout doesn't tell, at that point, if I don't see this section here, doesn't tell me what's what's the content of this automatic inverter layout? So maybe a good idea is, let's say, I'm calling this 3-core 1, and just give input and click somewhere else, hit tab or return on your keyboard whatsoever. And this one we call 3 power 30, for example. And you see as soon as I'm do changes here, also here changes are applied. So it's very easy to identify what's meant with this layout and this layout. Very, very easy. So at that stage of our planning, what did we do? Well, in the planning we said what kind of roof areas we would like to use, what kind of manufacturers we would like to use, and we had a automatic layout. When we found we satisfied, or now we're taking 2-dimensional layouts. In regard one, we labeled 3-core 1, and the other we labeled 3 power 30, and that's the one that's present currently. So now you could hit simulate if you don't want to take anything further in regard, but you know, most of the times it's from our experience that well, you would like to take some more things in regard, such as consumers, for example, because you don't selling your PV planning projects just by, you know, the global or theoretical annual yield, but you would like to give your planning more substance in terms of realistic results. And this can be provided by adding consumers. And you just click on that, add consumers, and you have now the opportunity to use these 3 tabs. So consumer profile, this is a huge list of predefined profiles. Maybe you don't have more detailed information about the nature of the energy consumption of your customer, and maybe it's really totally fine to work with that. On a commercial level, maybe it's interesting because your customer has an Excel file or a JSON file, or let's say data in a digital manner from his electricity provider, and you would like to work with that. Yeah, great, that's possible. So if that's provided, you will click on upload new profile. You will give this profile a name, a telling name and a telling description. If you want to use this profile only with this specific project, you would activate this checkbox, but beware, if you make a copy of the project, this profile will be no longer available. So most of the time you don't want to check that. Then, yeah, choose the file type either from CSV or JSON. So these are the 2 file types that are accepted. CSV stands for comma separated values, and JSON is a more or less XML-based file format. If you stick with CSV, there's some more values to be done. If you go to JSON, you see all these values are disappearing, but you need to make sure that the JSON file's content must follow specific specifications. But most of the time, CSV is what you are about to import. So the consumption you need to clarify if the consumption was given in kilowatt hours or watt hours or just watt or kilowatts. If it was a leap year, so 366 days, or a regular year, 365 days, what's the CSV separator in the document? And as CSV stands for comma separated values, normally you would expect to have a comma, but most of the times you will end up in finding it's a semicolon that separates the values. Here you need to check where's the first value. Is it in the first row, in the first column? Well, if you have headers to the table, it's definitely not in the first row, maybe in the second row, whatsoever. As I'm German, this is now German here. And you see, well, here you see these protocols here, and you could add, list them. I'm not going to do that. Hit this button, and you see, as just in Excel with a text file import, you see if the separator works, if the definition of row and column is working, and then you hit save. So this is with own profiles. which is very precise. And let's say once you take one, you could change the consumption. Still use the profile, but maybe a different value here. Consumer manual definition, that's something we are providing, but to be honest, I'm pretty much sure never ever, no one ever used this because it's really pain in using. You see, well, you have a consumer name, the consumption, the number, which weekday is it running, which hours, maybe in the morning and not in the evening, and maybe if you have a clothes dryer, you would say, well, and we have a garden and it's running from calendar week 1 to 21 and from, let's say, 37 to 53, just as an example. So you could do that. Nobody actually does that. In our case, let's say we didn't receive yet a profile from the customer and from its electricity provider, but we say, well, it's a commercial a project on a commercial building, and we say, well, yeah, we would like to say, well, commercial in trade and commerce in general, and the guy says, well, this something we delete, and the guy said, yeah, last year we had an energy consumption of 150,000 kilowatt hours. I could combine that, so maybe whatever. There's a night charge for a day charge here, and you could give here some input. So these are predefined values. You could change at any time. So you could combine consumption profiles if you want to. In our case, we say, well, we just would like to work with one. So now I have this consumption profile here, and I could add some battery or electric mobile. Let's say battery here, and let's say I'm changing. I'm taking BYD as a manufacturer, and I'm taking whatever this one here, and I'm not only taking one of these but 5 of these, and I'm choosing add. So this is now added here, but I could say, well, here to make it totally precise, I'm taking a Model S 90D, and as a charging, I'm charging on AC side, but type 1, level 2, and my mobility profile is a daily profile. Performance ratio on the battery, and also again here you have a pretty good explanation. Just hover over the mouse and we leave it like here, and deep cycle threshold, we also leave it like that, and you just add it just for demo purposes here. If it makes sense, it's up to you. And I also hit save that. So now again, 2 roofs with all the modules there. Manufacturer is selected. It's not simulated yet. We have 2 inverter dimensioning layouts that have been created automatically by the software. We have selected 1 consumer with a total annual consumption of 150,000 kilowatt hours. We have selected batteries. Someone needs to mute its microphone. So. And we had 5 times the battery here, plus electric mobile. And now that's the point where I say, well, I would like to simulate these 2 and to get an idea which of these 2 variations is the one that serves best results. And keep in mind, the larger my projects are, and the more of parameters that need to be taken in regard, the longer the simulation will take. And as I said, well, here in this example, I have batteries and consumption and an electric vehicle that needs to be taken in regard. Yeah, the simulation takes a while. So the 3 power 30 simulation but it's not actually 30. It needed to be 20,000, but yeah, whatever. Now serves an energy output of 16,000 kilowatt hours per year, and this one is in brackets only 15,000. I could get some more values here. So whatever, just go to the yield values, and still, if you see, if I change here the inverter layout, will remain here in this view, which in my opinion is very handy. And you see how these values are changing. And if you go to the energy balance, it's also changing here. And I have some different losses here because I have different inverters that are about to be used. If I go to the output pane here, I see a couple of different graphs still here. Also the yield values, which in my opinion is very, very handy. There are some combined graphs, so these are the single graphs here, and I have some combined graphs here, which are in my opinion very good. I see the yield losses here from and to, so input and output side. I have the project horizons, which is very interesting. So this is the horizon that will be calculated automatically or taken from Meteor Norm. That's the database and software that stands behind the provision of the horizon and the climate data. The climate data itself, you see them here. So this is the Meteor Norm version, the build date, and the year that was taken in regard. And that's very interesting here. We have a difference of the global radiation and the air temperature. And you see different stations that have been taken in regard. And that's very unique here. It's not only one, the nearest that's been taken in regard. That's the nearest would have been Freiburg. But also, in the area of Freiburg, there are some stations taken in regard. Why? Well, if you take whatever 10 or 20 years in this specific location for a specific day, let's say July 1st, maybe in the last 10 or 20 years, on this specific day, on a specific time, you had always clouds in Freiburg. But you maybe only in 50% of the cases, you had clouds in Schaffhausen or in Strasbourg. Yeah. And to interpolate these situations here leads to a more precise result than just if you would take only the figures for Freiburg in regard, because the future might look very differently. So that's the mathematical idea that stands behind the taking more than one station in regard and do some interpolation inside the calculation of the radiation and air temperature, because that's different in terms of being regarded. So in my opinion, very, very interesting. Horizon. Also interesting because if you go back, if you go back to the position tab, you see there's some interference area of the roof, and it has a height, and as it has a height higher than 100 millimeters on top of the roofing, it will be taken in regard in terms of shading. So a shading object is created here, but these are not taken in regard for the simulation. That's a very, very important fact. So the calculation of shades here on roof is not taken in regard for the calculation of the annual yield. If you want to take something in regard in terms of shading, only shading that appears on the total of the roof will be taken in regard. So, and this needs to be generated manually. So let's say at the side of the building, there's another building that produces some shade, that probably produces some shade. So if you go to the edit section in the horizon, you see the blue line here stands for the horizon, is created automatically. And the orange line is the rising and or is the line for the sun on December 21st, and the yellow one is the line for June 21st. And interesting here, and it's also an important hint, south is 0 here, and east is minus 180 and west is plus 180. And that's totally different from the roof section. If you go to the roof section and remind yourself here system alignment and you go over this eye, you see north is 100 and south is 180. And the reason is, here in the eDesigner that we take the shading in regard, and it's easier to define the shading here because it has more effect. We could have said north is 0, but then if you have some shading object totally in the south, which actually makes a huge impact on the installation itself, then you would have to define two deviations of the horizon, which actually is more effort and actually doesn't make sense. So we decided to change here and to say, well, 0 stands for south. So let's say we have a building somewhere here to the so that's east of south, and we say it starts at minus 50 and it ends at, let's say, minus 10. So that's the left. So azimuth start stands for the left border of the building. For the right border is azimuth end, and the top of the building is the horizon. So let's say let's here 35 degrees. And if you want to see the result, hit generate, and you will be prompted with a message, because if you did some simulation before, that if you change the horizon, the planning, the simulations results are no longer valid, and all the plannings need to be simulated again. You could say, well, do this automatically, which I'm not doing here, and hit OK. And now the horizon will be changed, and it's a drastic change here. You see, this is a tall building. And the good news is this horizon, this adapted horizon will be stored, and once you create a project with the same project address, this horizon will be taken in regard automatically, so you don't have to do it twice. So we go back to the dimensioning layouts and we say, well, this was the better one, and we had here 115,000 and here 160,000, 16,000 and something. And so we're gonna see it's okay. It's not to be expected that this now has a better output than that one. And you see, it's a drastic change. We lost something like 6,000 kilowatt hours per year. It's a drastic loss, which is needs to be taken in regard in my opinion. So it actually makes sense if you have a tall building or a tree or whatever. Please do the work and change the horizon here. The graph section is also interesting because short explanation, maybe you say, well, it's nice that you have some single and combined graphs, but they're not really serving the values in one graph that you would like to see. And you could either change these values in graphs, or you could create your own one. So add a combi graph. This could be single or combi. It doesn't mean it needs to be a combining graphs, but most of the time it actually is one. And you say, well, okay, I would like to see the yield on the AC side, but it's not red. No, it's something positive, and positivity, in my opinion, is green. And you also want to see, let's see, what's taken from the external grid, and that's something you don't want to have. That's something critical. It costs you extra money, so that's going to be red. The self-consumption is maybe neutral, so we take some gray value here To external grid, yeah, super positive. You're selling something, and maybe we take, let's say some whatever lime-ish thing. Maybe battery charging and discharging, and maybe whatever. You see, you get the idea. Mismatching losses, etc. And maybe we add some. So this was our kilowatt hour. Maybe degree of self-efficiency, and we say, well, this is also something good. So we also want to have some greenish color here. So this is the efficiency, and this is in percent. And you see, also the colors are here in this legend to make sure it's easy to comprehend. So I could give this a telling name, and let's say in my example, it's my first name, Stefan, and maybe I say, well, I would like to have filled graphs for whatever reason, just for design reason or aesthetic reasons or whatsoever. And if I say, well, don't show the preview, you see I don't see a preview, so that's not really rocket science. It's also pretty much self-explaining. Hit save. And now if I go back to the output, you see there's this Stefan graph here. And you see all items here, also part of this table here. So you could create a couple of these, and you don't need to create them every time for every new project, but they will be present for you for every new project you are creating or existing project where you go into eDesigner. But if you go back, you need to be aware. If I would have something here from battery, and that's actually the case, this graph will be not present if my planning will not consist or will not have batteries as a parameter, as an asset. So it will not be present. So that's something if you have to have in mind if you have a different planning without any batteries, and you go to the output section and you're missing your graph here, be aware it's not missing because that's a bug, but something that should be displayed in the graph is not part of your planning. So once you're satisfied with that, you say, well, it's active, and the three power dimensioning layout is the one that we would like to use. It's maybe the part where you say, well, I would like to do the stringing of my project, and you see, well, there's some stringing already done. I'm changing the roof to do the string on the other side of the roof. And it takes a while loading, and you see, well, everything is vanilla here, and I start my stringing. I could use automatic horizontal stringing, but you will see actually it doesn't make sense. So it doesn't make sense if you have interference areas, because the software doesn't detect them and say, well, I need to meander here, and then and actually you wouldn't build it like that. At worst is here in this example vertical. you wouldn't do that at all. But sometimes it might be interesting if you use an automatic stringing and you say, well, parts of the string is great, but other parts are not great, and well, maybe you just delete these other parts, and maybe you restring the other parts up to your personal needs. That's something that's interesting. If you say, well, I would like to do it completely on my own, and you did some auto stringing here, vertically or horizontally, just click on reset to reset the planning. You see, once you did an auto stringing, you see this icon here, which I can select and I can move around, and this is just the penetration point of the roof, which is not used for anything currently, but could be used in the future. So it's not mandatory to use that. So if you want to do the stringing manually, you see the list of strings here. So 3 inverters, 3 strings, 22, 22, 21, same for all. And you if you remind yourself of the eDesigner layout, that's actually what was needed. And maybe I start here on this side. And how do I start? This is the tool which I want to select for the stringing. And as soon as I select it, you see the first string becomes selected automatically, and I need to, yeah. Did I start here? Boom, 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 no. So I start here, and I could now click on the first module, click on the next, and I could select or put modules to the string just by clicking. But I could also keep the left mouse button pressed and just hover over these modules. And if you check the table on the left side, now 16 modules of 22 are string, 17, 18, 19, 20, 21, 22. And the process is released. You see the tool is switching to the next string. This one is completed, and I could continue with my drawing. Yeah, you see, it's very, very easy to be done. Yeah, maybe I go from here to here, and maybe from here to here. I don't know if that makes sense, but I'm just for demo purposes. Oh, I was lucky. I used that one. Maybe go from here to here, maybe from here to here. And maybe I go from here to here, from here to here, and I completed my task here. Very, very easy to use. I could with the eraser tool, I could erase strings. I could say, well, I have you see this exclamation mark, so now 1 to 21. I could say, well, I'm using this selection tool. I could click on the first module, hold the Shift key on my keyboard, click on this module. Now you see a number of selected modules. I'm selecting this string, and I say, well, please select these modules. Yeah? That's another way to string it. But as you have seen, in my opinion, this tool is really, really easy to use. It has lots of benefits. The string is automatically completed and changed to the next string that needs to be completed. Also here, colors can be defined. You see now this is red. Maybe you want to have some blue here, and you get the idea. So also very, very easy to use. Yeah, I'm not completing the meeting in time. Now it's 11:02. There's something I need to show, and if you want to follow, you're invited. If you need to quit the session, yeah, you could see that in the summary video of this session. I'm apologizing. eDesigner itself, it's so huge from its functionalities and capabilities, and there's a lot to explain. So yeah, please accept my apologies. So these two examples here were automatic layouts. I'm also setting this as inactive, and I say, well, I would like to add a new planning just for demoing the manual layout. And again, I say, well, add roofs. Yeah, we would like to add both sides of the roofs. And now I say, well, no, I have something in mind. Just let me get and I would like to say, well, I would like to do the selection totally my way, totally manually. And so not selecting here manufacturer here, but adding dimensioning layouts manually. And now I'm transferred to the dimensioning layout sections, and I need to say, well, add inverter. And then, yeah, this is something you already might know. I'm choosing the manufacturer, and now I need to say, well, I would like to use, maybe, no, this is, doesn't make sense. Let's say these two. I could add this later if I want to, but these are the two inverter models that I would like to use manually. And now you see, well, this is the two models here. And I had in mind, from my remembering, that I need 3 from these. And I forgot about the strings and I didn't make notes. I'm going here to the west side and also here to the west side. And I guess it was 20. Two with 22 and 1 with 21, if I remembered that correctly. I'm not sure. We'll see. Yes. Yeah. So that's working. And maybe here on the east side we're using 6. 6 with also 2 with 22. I wonder if that's serving good results. Yeah, you see, it probably doesn't serve good results here because it's not actually working just by doubling it. Okay, 2 is 22. You're fairly outside the specification. And that's not working here. You see, so you get the idea. So I need to delete that. I need to add an inverter, and so I'm taking that one. Was that right? Yes. Okay. So that's east 3 times 2 with 21. So I could really tap through that 21 and hit OK. Also, again, the inverter check will be done automatically in the background. Once the results are fine, you could use that. So you see that how the manual selection is working. You could if you change the strings, you could say, well, I would like to delete that or change the amount here at any time, as long as you're in the boundaries of the numbers of modules that are needed for your for the roof that is assigned. Then you could proceed. So the number of modules must fit, plus the boundaries of the specifications of the inverter needs to be met by your assignment of, let's say, number of strings and numbers of modules. Good. So that was a very easy task, and again, yeah, I could manual tree. So, and yeah, I could save that and then simulate it. And again, yeah, I would. It's the same yield I do have here because the horizon was changed, so this will be taken in regard. Yeah, so it's actually the same. But as I said, on the output section, the graph that I did earlier is not present. So if I go to auto layout, I will remain in the same view here. So in the output view, and the graph becomes present. So if I go here at PV planning 3, it will disappear because I didn't have any consumers, any batteries that should be displayed here in the graph. So actually, before running into an error, the option of this specific custom graph is not present. Good. So yeah, 9 minutes. It's okay. I think we can live with that. Yeah. If you have more plannings to one project, and be sure to use to let's say mark the one that you really want to use in the electric section. The one that you want to use, mark that active. Mark the other one inactive, because otherwise you will end up in having strange results in the electric tab, because it's really relying on what's active there to be still in sync, if you will. Good. Thank you for your attendance. It was a pleasure to present eDesigner and electric. There's still some parts missing, I'm sure. One thing I forgot. The favorites here. So you could choose, you could generate your own inverter favorites list that would be displayed if you do automatic plannings. Same goes for the profiles and for the batteries. Just play around with it. It's very pretty much self-explaining, very easy to use, and maybe really handy. Project report. This section is the very same that appears in the output project report. There's some predefined projects here. And the idea is, maybe you say, well, extended reports, but I don't want to have the energy balance here. Or you have a simple report and you would like to have the energy balance. Click on show. That means the PDF will be generated and will be offered for download. If you're in the in the output section of your project, where the bill of material is to be generated, takes a while. Maybe I could. No, I need to wait. And if you start the project generator, that's what we call it, you could either configure eDesigner components here or here. And again, it's like what you've seen earlier. And again, it's exactly the same. So here, with every project report, total project report you're generating, you could adapt the contents in terms of the eDesigner calculations and data at any time with this functionality here or here. Thank you for your attention. I will leave you. Have a good time. Bye-bye.